let us look at using the unit circle and also the graph to solve for theta when sine of theta equal n, where n is a number. We're going to also look at some specific examples with number. Now, here I have the unit circle, which you remember is a circle of radius 1. Alright? Now, we're going to also look at the graph of the function sine theta, what I call sine theta. Let's just quickly look at the graph of sine theta. Just as a review, you have 0 degrees here. Say 360 degrees end up here. So in the middle you have 180. Here you have 90, 180, 270, and so on. Now, this is 45. Now, you may find the sine of 0 degrees. Use a calculator. Put it in, or make sure it is in degree mode. When you find the sine of 0, you get 0 right here. When you find the sine of 45, you get 0.707. Which say is somewhere about here. The sine of 90 is 1. So let's put the 0.707 further up here. And the sine of 90 is 1. Alright. If this is 45, then in the next part you have 135. This corresponds to 135. What is the sine of 135? You go back down to 0.707. So it's not going any higher than 1. So put 1 here. This is 1. The sine of 180, you get 0. You just back down to 0. If you go 180 and go 45 more, you're going to go at 225. So this is 225, and then you say what is the sine of 225? It's going to be negative 0.707. And then the sine of 270 is negative 1. Then after 270, just to make the graph line up, this would be 315. What is the sine of 315? You get negative 0.707. It's going back up. So it go down to negative 1. Sine of 360 is 0. So if you should plot the graph and draw a smooth curve, although my curve probably not that smooth, but you get the idea. Alright, you get something like this. You could have even found a graph of 1 degree, 2 degree, 3 degrees if you want. But you would have a lot of points to plot. Alright, so you have an idea what the graph is like. So this look a bit messy, so let me redo this graph. So what we have here, you have the y-axis, you have the x-axis, and you have the curve. Alright, good. 360, 180, 90, 270, and so on. Now, the thing is, we have sine theta equal n. Just as a matter of revision, this is our triangle. You remember that angles are measured from 0 in an anti-clockwise direction. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is theta. Opposite over hypotenuse. This is our opposite, and this is our hypotenuse. Opposite over hypotenuse will give us n. Alright? Now, here, if we consider this other triangle. And this is our opposite here. And this still remains our hypotenuse. The hypotenuse is the radius of the circle. We're going to get the same value. But remember, the angle, the new angle, we must measure it from 0 in an anti-clockwise direction. So to get that angle, you'd have to go to 180 and go back up theta. So what you have, sine theta is the same thing as sine 180 minus theta. You can try it and see. So, for example now, sine theta is equal to a half. What is the angle theta? Interesting. Well, theta is the sine inverse of a half, which is what? If you use a calculator and find the sine inverse of half, 0.5, you get 30 degrees. Good. But that now, sometimes referred to as the principal angle, the main angle. You have other angles that it works for. If you go from here, you have this triangle. If this was 30, then it would mean that, being that this angle is 30, the opposite over the hypotenuse is half. But this triangle over here, the same argument can be made about it. The opposite over hypotenuse will be half. But what's the angle measured from here, going around? That angle, call it this theta 1, call this theta 2. It's going to be 180 minus 30, which is 150, is the sine of 150 half. Try it with a calculator. 150 sine, you get half. Right? Alright. Now guess what? Remember, the circle is spinning and spinning and spinning around. If you do like this, pass 360 and come back here, you would have 360 plus theta. So suppose you consider a third angle, which is 360 plus 30 degrees, which is 390. Oh, what did I write up here? I should say the sine inverse of 150 equal half. All right. So here, sine inverse of half is 30. Oh, not the sine inverse, my. The sine of 150 equal half, my. The fact that the sine inverse of a half is 30 means the sine of 30 is a half. The sine of 150 is also a half. But what about the sine of 390? What is that equal to? Let us use our calculator on screen and test this thing. Now, this is already in degree mode. So, the sine of, what is it again? 390, 390 equal half. So, for theta, it could be 30, because sine 30 is half. It could be 150, because sine 150 is half. It could be 390, because 390 is half. Are there any more angles? Let us see. If you go right around, go to 360 and go right around, add 180 more, and back off, you would have 360 plus 180 minus 30. Let's see what would happen. I had made another copy of our unit circle here earlier. Let's see what would happen under such circumstances. Let's call that other angle theta 4. So we have 360 plus 180. So 360 plus 180 would take us 360, 180, and then we go back up here and see what happens. 360, 180 plus 180 minus 30. What does that give us? 360 plus 180 minus 30. Let us see. 360 plus 180 minus 30 degrees gives us 510 degrees. Now, notice when we do that, we're lining up with this triangle because we go 360, 180, and back off. So we back off 30. So it's the same opposite over the hypotenuse. Will the sine of 510 be half? Let us see. Sine of 510 degrees. All of these are degrees, remember? But anyway, we're going to see what happens when we try that. No, that is 510 degrees. What is the sine of 510 degrees? 5 equal. We get half. In fact, the same argument can be made if you go 360 and go 360 again. That is what? 720, and then 30 more. And find the sine of it, you're going to get half. And if you go 360 plus 360 plus 180 minus 30, find the sine of that, you're going to get half. So there's an unlimited number of angles whose sine give you half. The first four are 30 degrees, 150 degrees, 390 degrees, and 510 degrees. All of those, the sine is half. We can continue and find more angles, right, whose sine equal half. Now, in order to deal with such a situation, what you're normally asked to do is to find the angle so that it is between 0 and 360 degrees. So there's some limit on it, all right? There's some amount of limit. So you're not asked to find an unlimited number of angles. Now, let us go over to the curve, the sine curve, and see. Sine 30. Now remember, this is y equal sine theta. These are the angles theta, and this is y. Now, the sine of 30. 30, say, somewhere here. Now, if you find 30 and project upwards to the curve, then you project horizontally. This will give you the sine of 30. So let us draw a line across. Now here, this is 30 degrees. You go up. When you go across, you're going to get half. Now, here, this is 150. Because the thing is, 150 says about here, about there now. If you project upwards to the curve, then go to the left, you get the same half. See that? What about the 390? How does that come in? Well, remember, here, I had stopped at 360, but the angles go on and down and down. You could continue forever and ever. But guess what now? You see, the 390, it would be 360 plus 30. It would come here at 360 and go 30 more. This little distance here is the same as this, the same as this. When you project upward to the curve, go to the left, you get the same half. Now the other angle, this is 180, 360, and then that other angle here would be 540 right here. If you say 540 minus 30, you get this angle, which is 510 degrees. You see? The 360 plus 180 minus 30. How it would go? It would go 360 plus 180. 180 is half of the curve. So from here to here is 360. Plus 180 more comes here. Minus 30 goes back right here. That's 510. You go to 510, project up to the curve, then to the left. You get the same half. The next angle, and you could go on and on and on and on, forever and ever, finding an unlimited number of angles. But you normally limit it to between 0 and 360 degrees, right? And you don't go further than that. Oh, here it shows the various angles who have the same sign using the unit circle and also the thing here, the graph of the function. Now the same argument will apply to cosine and also tangent, but we'll look at that in another video.